of which human beings started to move from the bullock cart stage to the automatic stage. Thus, the automation age began in 1800s. So, what are the advantages of automation? The quality of the finished product is very good. The time is saving, reduced labor cost. Example, cars. Okay, the cost per unit will be less. There are different types of automation. One is the fixed automation, the soft automation, etc. So, this is how the evolution of automation took place. First is fixed automation, then the programmable automation. Now we are in the era of flexible automation. That means we can manufacture a variety of products by just changing the software. Enter one software, one product will be manufactured. Enter another software, another product will be manufactured. Okay, so this is how the flexible manufacturing systems takes. It makes use of CAD, CAM, SIM, or the AutoCAD. It's a combination of many programmable automations, and there'll be one mechanical setup used to manufacture one particular product, another mechanical setup used to manufacture another particular product. Everything is controlled by a central processing unit. So this is how the flexibility in manufacturing is carried out by making use of CAD, CAM, and SIM. Some examples of automation process I'll be giving. One is a mechanized assembly lines, the NC machines, etc. Computer system for weather forecasting, process control and instrumentation, then retail, video surveillance, then laboratory logistics for medical space and defense applications. Nowadays, in the 20th century, each and every process automation is used. So this is how the automation age evolved into the robotic age in the early 1950s. As the years rolled by, what happened? The science, engineering, and technology started to improve. The diode were invented, the IC chips were invented, the microprocessor, microcontrollers, the PLCs, computers were invented, and thus the era of AI began. So this is how we can define robotics. It is a branch of engineering that mixes different study different types of robots, the simulation, design, mixes various engineering disciplines such as electrical. The father, we can say the father of engineering is electrical. From electrical, electronics came into the picture. And then computer science, instrumentation, mechatronics, etc. That means if you study all these subjects, it means that you have studied one subject called as robotics. In robotics, what it is there? Just actuators are nothing but electric motors. How do you control electric motors? Various types of control strategies are there. One is power electronics based control, the thyristor control, SCR control, the PWM control, the sliding mode control, etc. So we can say robotics is a combination of machine tool technology and computer science, or it's that branch of technology that deals with the design, construction, operation, and applications of robot. So the word robot was coined by the Czechoslovakian playwright called as Karel Čapek in 1920. Okay, so these are the three laws of robotics, like how the three Newton's laws of three motions are there. Okay, this is how we define a robot. A robot is nothing but a reprogrammable multifunctional manipulator designed to move various objects, tools, materials, or specialized devices through various programmed motions for the performance of a variety of tasks. Or you can also say the Japanese Institute of Robotic Association defines a robot as a replica of a human hand. Okay, so yeah. So automation and robots. So as I already told you, there are two types of automation. One is the hard automation and the soft automation. Say human hand, you take it has got 27 degrees of freedom. You can take that. That means there are 27 motors. Each motor is controlled by a particular. It can be a linear motor or it can be a rotating motor, etc. So there are 27 degrees of freedom in a human hand. We can see that in each and every finger, the small actuator or a motor is being done. So what is the input to the motor? The input to the motor is electrical energy. What is the output of the motor? The output of the motor is nothing but a angular displacement. Okay, like a fan, you take a fan. Fan is nothing but a motor is nothing but a electromechanical energy conversion device. So for each and every joint, one motor has to be done, has to be put, and each and every motor is being controlled. That's how we do the control of the three x, y, z, like in field theory, rectangular coordinates, the cylindrical coordinates, and the polar coordinates. So for positioning the aeroplane in the 3D space, you have three coordinates to move up, down, left, your roll, your pitch. So it has got 6 degrees of freedom. So we can classify robots on the basis of drive technology, workspace, and the type of motion, and the intelligent generation. You should know what is a drive. A drive is nothing but there are three types of drives. One is a electric drive, hydraulic drive, and the pneumatic drive. Okay. Now we can say that electric drive is nothing but motor which is controlled with a interfacing circuitry, right? So electric drive is nothing but a electric motor to which a interfacing circuits is there. Just wait. Up. This is an, I think, articulated robot. This is an articulated robot wherein I think there is some. No, I'll come back. Just to come back. Yeah, here I will show. You can see here. I think the system has got hanged. Just a minute. System is. As I already told you that there are three types of robots: a Cartesian coordinate robot, rectangular coordinate robot, and the polar or coordinate robot. Here you can see an articulated robot in which there are three joints: the base, shoulder, elbow. For each and every joint, a motor is being put and which is being controlled. So, articulated robot means all the joints are rotary in nature, like just like a motor. You can say a Cartesian coordinate robot has got what you call XYZ coordinates. One second. Just I'll just connect back because the PowerPoint is not responding. Just into 1 minute. Shit. Yeah, I'll rejoin once again after restarting the system. I'll just restart the system once again. There's some problem.
Okay, sir. Don't left anyone. Sir joined in 5 minutes.
Yeah.
Okay, so due to some technical issue, sir couldn't give the presentation on this topic. So at the last, I will convey my vote of thanks. For that, for vote of thanks, I hand over my charge to my colleague, Professor D.M. Korke, sir. Over to you, sir.
Okay, madam. Am I audible?
Yes, sir.
Okay. So good afternoon, everyone. I am Professor Koke DM, and I am here to present the vote of thanks. First of all, I would like to thank our guest webinar speaker, Dr. T.C. Manjunathan sir, for enlightening us with their knowledge. Dr. T.C. Manjunathan sir told us about the automation, then types of the automation, advantages of the automation, and applications of the automation in the industrial drives. Next, sir also told us about the robotics, their definitions, types of the robotics. So that was really informative. So once again, I would like to thank Dr. T.C. Manjunathan sir for taking out time from their busy schedule and enlightening us with their great knowledge. I would like to thank our beloved principal, Dr. K.J. Karande sir, Vice Principal and IC President Dr. H.G. Kulkarni sir, and our Honorable HOD, Dr. Aryam Patil sir, for giving us permission to organize this webinar. Next, I thanks webinar coordinator, Professor A.S. Sindhu Madam, teaching and non-teaching staff for their valuable contribution to make this event successful. At last but not least, I thank all the students those who have participated in this webinar. So with the permissions of all, I declare today's webinar is over. Thank you, sir.
Thank you, sir.
Sorry,
Thank you,
I'll,
everyone.
sorry, I'll try to make it as a next time some big event
Okay,
because
sir.
Okay,
of
sir.
some
Okay.
this
Thank
one.
you, sir.
Okay, sir. Always welcome.